So what if an AI could do more than just see a picture? What if it can actually understand the story behind it? Well, today we're going to dive into a pretty fundamental shift in AI. We're talking about moving beyond just predicting words and instead predicting the actual meaning of what it sees.
But let's back up for a second. Have you ever noticed how even the most advanced AI vision models today just feel a little slow, a little behind the curve, especially when you need them to act in real time? So what's really holding them back?
Well, it turns out the problem isn't with the camera, it's with the brain. The way we've been building these vision language models, VLMs, has some really serious fundamental limitations baked right in.
Okay, so here's how it works right now. When an AI wants to describe an image or a video, it does it, well, pretty slowly. It's something called autoregressive generation. Look, all that really means is that it predicts the description one single word at a time. It's this very rigid, step-by-step process.
And this whole word-by-word approach, it creates two massive problems. First, it's just incredibly expensive to train. The AI wastes a ton of energy trying to get the phrasing just right, the perfect grammar, the perfect style, when all we really care about is the core idea. And second, it is so slow. Generating a description one word at a time creates this lag, which is a total deal breaker for anything that needs to happen instantly, like, say, a robot trying not to bump into things.
So what's the solution then? Well, it's a pretty radical shift in how we think about this. What if instead of predicting the messy, complicated world of words, we just predicted the clean, simple, abstract world of meaning itself? Okay, this is the core idea right here. The old way, it gets totally bogged down in the specific words, the tokens. But this new way, it's called embedding prediction, goes straight for the good stuff. It focuses only on the core semantic meaning. You can think of these embeddings as like a secret mathematical language just for ideas. So instead of wasting time learning the exact words a person is running, the AI just learns the concept of a person running. Way more efficient, right?
Here's a great way to think about it. It's like the difference between memorizing an entire textbook word for word and actually understanding the core concepts. You see the difference? This much smarter approach is the whole idea behind a new model called VL JEPA, and it is just way more efficient and powerful.
All right, so how does this thing, the Joint Embedding Predictive Architecture, or JEPA for short, how does it actually work? Let's pop the hood and take a look.
It really boils down to four key parts. First, you've got an X encoder. Its job is to take the visual input, a picture or video, and basically squish it down into one of those meaning embeddings. Then, a Y encoder does the exact same thing for the text description. Now, the predictor. This is the real brains of the operation. All it does is learn to predict the text embedding just by looking at the visual one. And finally, you have a Y decoder that can translate that predicted meaning back into regular words. But, and this is key, only when we ask it. So you can see that whole flow right here. The visual input goes in, gets turned into an abstract idea. Then the predictor looks at that visual idea and learns to create the matching textual idea. The really crucial part is that this entire learning process happens in this super efficient abstract embedding space. It completely skips that slow, clunky process of generating one word at a time. It's a total shortcut. And because this whole architecture is built around this core idea of meaning, it turns out to be incredibly flexible. I mean, we're talking about a single, unified model that can handle a whole bunch of different jobs without needing any custom tweaks. So, for starters, it can generate descriptions. The classic stuff, like creating a caption for a video.
But it could also answer questions about what it's seeing or classify objects in an image.
And maybe coolest of all, it's amazing at retrieval. You can just type in a description, and it can instantly find the exact video that matches it from a gigantic library. Super powerful. Okay, so the theory sounds amazing, right? Faster, better, more efficient, but does it actually work in practice?
I mean, that's the real question, isn't it? Does this new approach actually perform better? Let's look at the data.
And honestly, the results are pretty stunning. In a head-to-head experiment, VL JEPA, that's the blue line you see here, consistently learned faster and performed better than a traditional word predicting model in red. This was true for both captioning and classification. It just got smarter, faster, with the exact same amount of data.
But here's the real kicker. Get this. It did all that while having 50% fewer trainable parts. Let that sink in. It's not just a little better, it's dramatically more efficient. It is literally doing more with less.
Now, all this efficiency unlocks a really cool feature, something that's a total game changer for real-time video. It's called selective decoding. So imagine this. Instead of the AI just constantly babbling, describing every single frame of a video, it can just wait. It can choose to generate a description only when the meaning of the scene actually changes.
And you can see how that works right here. As VL JEPA watches a video, it's creating this constant, silent stream of meaning embeddings. Then a really simple, lightweight decoder just sits there and monitors that stream. As long as the meaning is the same, the scene is static, it does absolutely nothing. But the second that meaning shifts, boom, a person walks into the room, a car turns the corner, it instantly wakes up and spits out a new description. It's like an incredibly efficient way to pay attention.
And the impact of this is just massive. To get the same quality results, this method requires nearly 3 times fewer decoding operations than a model that's just chugging along describing everything all the time. This is what finally makes real-time AI vision a practical reality. Okay, so let's pull all of this together. We've talked about the tech, the efficiency, but what does a breakthrough like this actually mean for the future?
Look, this is way more than just some cool academic paper. This matters because it unlocks AI that can finally operate at the speed of our world. We're talking about robots that can actually understand and react to a busy environment in real time. We're talking about smart wearable devices that can offer you genuine help right when you need it. And honestly, it points to a much more efficient, much more scalable way to build the next generation of machine intelligence. So, by learning to predict meaning instead of just spitting out words, AI is taking a huge step closer to genuinely understanding our world. And that leaves us with a pretty exciting question to think about. If AI can finally see and understand our world in real time, what will it help us do next?